Hi and Assalamualaikum. So, my team and I will be present about power generation sea wave. So, my name is Muhammad Wafiq bin Muhammad Azhar. I will introduce about you my team members. First, Muhammad Afiq Ifan bin Abu Talib. Second, Abid Ramadan bin Zaini. Lastly, Matthew Sangat, anak Stephen Jano. So, the list of content is first, introduction. Second, basic operation. Next, related diagram. After that, example of real site. Next, impact towards society in terms of health, environment, safety. So the lastly is reference. So for the introduction is sea wave renewable energy, or usually called wave energy or ocean wave power, is a type of renewable energy that converts the motion of ocean wave into electricity. Instead of burning fuel, it uses the natural movement of seawater, which caused mainly by wind. It is a form of clean, renewable energy that harnesses the up and down motion of waves to generate electricity. It uses devices that capture the movement of wave technology that's been in the works for decades, though it's still at an early stage of development compared to solar and wind energy.
To understand how we harness the power of the ocean, let's look at the basic operation of the wave energy converter. For step 1 and 2, it begins when wind travels across the ocean surface, creating kinetic energy in the form of moving waves. Step 3, these waves interact with specialized machine, in this case, point absorber buoys, which capture that physical motion. And finally, for step 4, an internal generator converts that mechanical energy into clean electricity, which is then sent to the grid. It is a simple 4-step cycle that transforms natural ocean wave into sustainable power for our societies. For related diagram, I have put 7 examples for the sea wave energy converter, which is attenuators, point absorbers, oscillating wave surge converter, bulk wave device, oscillating water columns, overtopping device, and submerged pressure differential device. Now, let's look closer at the internal working principle of this device, which is a permanent magnet linear generator. For step 1, the process starts at the surface with kinetic capture, where the buoy moves vertically with the wave's oscillation. For step 2, the motion is transferred down to the tether, then to the translator, which is contain permanent magnets. It moves up and down linearly within the unit. For step 3, this is the core of the technology. It is electromagnetic induction. As the magnet moves past the copper stator windings, they induce an electrical current following the Faraday law. And finally, for step 4, a restoring spring at the base provides the tension needed to pull the translator back down as the wave passes. By using this method, we bypass the complex gear, making the system more efficient and durable in harsh marine environment.
Now I will present about example of real site. I will explain about the Mutrico wave power plant located in Spain. This power plant is known as the first commercial wave power plant in Europe and started operating in 2011. The plant used oscillating water column or OWC technology. When sea wave enter the chamber, the water movement compress air inside it. The compressed air then spin turbine to generate electricity. Mutrico has 16 turbines with a total capacity about 296 kilowatts. This project shows how ocean wave can be used as a clean and renewable source of energy while reducing carbon emission. Now I will talk about the CETO. wave energy project in Australia. This project uses underwater bows placed beneath the ocean surface. The movement of sea waves causes the bow to move up and down, creating pressure that helps generate electricity. One special feature of CETO project is that it can also produce desalinated water in addition to electricity. Next, I will explain about Sehwa Lake Tidal Power Station in South Korea. This is the largest tidal power station in the world. It uses tidal movements which are caused by the rise and fall of sea levels to generate electricity. When seawater flows through the turbine during high and low tides, electricity is produced. The station has large generation capacity and helps South Korea reduce dependence on fossil fuels. Besides generating renewable energy, the project also helps improve water quality in the surrounding area. This shows that ocean energy can provide both environmental and economic benefits.
Next, I will explain the impact of sea wave power generation towards society in terms of safety, environment, and health. For safety, sea wave energy reduces risks related to fossil fuel mining and transportation. It can also provide a stable electricity supply for coastal communities. However, workers involved in offshore installation and maintenance may face dangerous sea conditions, especially during storms. Damaged equipment may also become a hazard to nearby boats and ships. For the environment, sea wave power is a clean and renewable energy source. It helps reduce carbon emissions and decreases dependence on fossil fuels, which can help reduce global warming and air pollution. However, the installation of wave energy systems may disturb marine ecosystems. Noise and vibrations can affect fish and other sea animals, while coastal scenery may also be affected. For health, cleaner energy production means less air pollution, which can reduce respiratory diseases such as asthma and lung problems. This improves the overall health of society. On the other hand, offshore workers may face health risks due to harsh weather and difficult working conditions. Noise from the facilities may also disturb nearby residents. In conclusion, sea wave power generation provides many benefits to society, especially in promoting cleaner and sustainable energy. But its challenges must also be managed carefully. That is all from our group. Thank you.